breaking the wall to link microbes and climate-smart farming. Pooja Manandhar, Nepal Bioscience Research Laboratory, Nepal.
Nepal, an agricultural country and a land blessed by nature, home to tallest mountain in the world, rich forest, fertile soil and incredible biodiversity, including microorganisms. But when climate change strikes, these blessings turn fragile. Agriculture collapses, forests burn, and livelihood disappears. These were the conditions that I witnessed and it demanded action. When I started, challenges were numerous. Environmental challenges like drought, degrading soil, biodiversity declining, weak carbon sequestration, accelerating climate risk, scarcity of fertilizer, especially the environment-friendly one, and it also contributed to the deterioration of the soil health and also people's health. Socially, convincing farmers to leave conventional farming practice was tough. Women and marginalized groups were often excluded from opportunities. Economically, no or very little funding made it difficult. Politically, it was even more challenging because we do not have a structured policy for implementing climate smart practices. Yet, I did not see the challenges as barriers, but saw them as an opportunity to innovate. I came up with an innovative solution, the climate smart sustainable agriculture approach. It was implemented in Nawalparasi, one of the fire-prone districts of Nepal. Through this, forest waste or forest biomass, once fueling forest fire, was managed and treated scientifically using windrow composting method, converting it into a nutrient-rich organic matter to which native, agriculturally beneficial microorganisms were added to develop eco-friendly biofertilizer, which is returned back to agriculture. We transformed forest waste into a resource for soil fertility, and it created circular economy and new entrepreneurship opportunities. The results spoke for themselves. Forest fire was reduced by 70% and enhanced biodiversity and soil health, boosted agricultural yield by 40% and hence food security. Waste is now of value and so is managed very carefully. The communities became the real drivers of climate solution. A community-run biofertilizer production unit was established under the leadership of women, and it provided green job opportunities for more than 400 people and also reduced youth migration rate. Women gained financial independence and were funding their children's education. We demonstrated a scalable, sustainable climate-smart farming model which connected science with communities. We also conducted the very first national conference on climate change and sustainable waste management where science made policy and already impressing many policymakers. Involvement of students in the project was impactful. People understood climate solution is not a distance theory, but could be practiced in their field, in their forest, and of course in their communities. We practically demonstrated that by transforming waste into a regenerative agriculture, Nepal could restore its soil, develop an alternative to harmful chemical fertilizer, fight climate change, and develop a resilient future. It was overwhelming to receive requests from so many communities and government bodies to replicate this model in their areas as well. It's great that Nepal is a habitat to so many beneficial microorganisms that I even built a mini library of these microbes for sustainable agriculture. Very surprising was to see a 90-year-old grandmother explaining and thanking for climate-smart agriculture. She shared food regained its taste and earthworm reappeared in her field. Most satisfying was to make people understand that Earth belongs not only to we humans, but also to animals and other creatures, and so we need to protect them, to protect our nature, to protect ourselves, and minimize climate risk. Food security cannot exist without climate resilient, and agriculture cannot thrive without sustainable land management. Nepal may be small, but its action shows that local innovation can have global impact. Thank you.
Do we have any questions from the jury? Yeah, well, I was counting on you.
So thank you, Pooja, for this is very innovative, I think. Are you transmitting knowledge on the biofertilizers, how to use them, or the chemistry behind that? These are two very different things. So are you teaching them to use it, or what the science is behind that? That's the first question. The second one is, what traditional knowledge from your communities went into creating the biofertilizer?
Thank you for the question. Like what we are teaching them is we don't actually teach them the whole biology behind them, because when we do that, they become really bored. So what we teach them is like we created a demonstration plot, and then like the forest biomass were unmanaged and it was fueling forest fire. So what we did was we collected those forest biomass and then treated scientifically, converting, like stabilizing it. And then I also isolated and identified microorganisms native to that place. And I did mass production of that microorganisms in my laboratory, and then I took it there, and we taught them how to use that, in a sense that like how to dilute it with water and in what ratio it should be mixed with the treated fertilizer, converting it into a biofertilizer. And the traditional knowledge is that like they were like previously also they were using compost, but in a manner which was not scientific. So they know what is compost. They knew that when something gets rotted, it becomes compost. So we actually use the same principle, but in a more scientific way, so that like after the development of the product, we used it in the field. Like previously they were very hesitant. They did not know that some microorganisms could do that, but after they saw the results, they were convinced, and now they are practicing the same thing. Yeah.
Yes, over there, please.
Well, quite often I'm not usually comfortable with the word teaching. I like engaging. So my question would be, what are you learning from the community?
Sorry?
What are you learning
What
from
are
the
you
community?
learning from the community yourself?
What did I?
What do you learn from the community?
From the community, I learned that when you join hands together, it really becomes strong. Like I saw how they were working as a team, and that was the major factor for the successful completion and implementation of the project. Yeah.
Any other question? Jury members? The audience somewhere? Yes? Yes. Over there.
Thank you very much. Excellent presentation. I really liked
Thank
it. I wanted to ask you, how transferable is this approach? So I understood that you're working now in Nepal. Can we transfer it to other places? Are these species that you have found endemic to Nepal?
Yeah, sure. Like it is a very replicable model, and as I also said in my presentation, that many government bodies are also approaching us, and we are replicating it to other provinces of Nepal also, and it is also replicable to other places where they are facing the same problem in like deterioration of the soil health due to the climate change. So it is really helpful. Thank you.
I think we had another question from the audience, so I was just showing. Jury members. Oh, sorry. Yes, thank you. So Mike, it's really at the bottom of the room.
Thank you for your talk.
Thank you.
I have two questions. If you keep taking out forest biomass from the floor, won't the forest soil degrade at some point? That's the first thing. And the second is, it looked like you were using open compost heaps, which in turn would have methane emissions. So have you thought about closed systems, such as anaerobic digestion? Thank you.
Thank you for the question. Like for your first question, like when we do the collection of the biomass, we make sure that we are not emptying the forest. So when we are collecting, we normally do for the invasive plant, and also if we are doing other like forest biomass, we leave certain portion in between so that it helps in retaining the soil structure or held soil together so that it do not cause deforestation or erosion problem. And for second question, like we did the open window composting aerobic process. It is like the firstly why we did this is because it is one of the mostly accepted one, and like we did not go for the anaerobic process because it is more costly than the aerobic one. So like, and also like in the place where there is not much facility, it's a little bit difficult to maintain the anaerobic conditions.
I think
So,
that's it.
yeah.
Yeah, sorry. I'm like trying to get you at the right place. So you can continue the discussion at the break. Thank you very much. Thank you.